Hi, everyone. Thank you so much for coming to our presentation this afternoon. My name is Maya, this is Jose, and we are going to be presenting kernel observability using eBPF made easy and approachable with Inspektor Gadget. Inspektor Gadget is an open source project. It is a CNCF sandbox project. For our agenda today, we'll introduce ourselves. We then have an interactive poll that I'm hoping will be an engaging part of the presentation. And as promised, we will give an introduction to eBPF, and we'll then introduce Inspektor Gadget. We have some demos to show you. We'll give you some background around how exactly Inspektor Gadget works, and we'll show you how you can use it as well. And of course, demos. Cool. So my name is Maya Singh. I am a product manager at Microsoft, and I am the PM for the Inspektor Gadget project.
And I'm Jose. I'm a senior software engineer at Microsoft. Can you hear me? Yes. Okay. And I have been working in Inspector Gadget project for 4 years now. Yeah, one of the maintainers and developers.
Awesome. Thanks, Jose. So we really wanted to open up with some system level challenges that folks may encounter with their Linux system. So whether that's debugging challenges, monitoring challenges, or security challenges, there are a host of problems that one might encounter that they might need help solving. So from a debugging perspective, you may encounter out-of-memory kill events. Your DNS queries might not be resolving. That's sort of the classic it's always DNS case. Or you might be facing deadlocks, which is when a process doesn't proceed due to another process using resources. From a monitoring perspective, you might have trouble identifying the source of high latency. You might be lacking visibility into CPU usage. You want to identify stress on your system coming from a specific container. Or maybe there's a process from a container that's excessively reading or writing to a file, and that's manifesting as latency on your system. And from a security perspective, there's always the opportunity to improve our ability to identify potentially malicious activity. Whether that's a shell being open on a Kubernetes cluster, which could be indicative of an attack, or validating binary changes in a container image, or even monitoring processes that are accessing the file system. These are all activities that we want to be able to make sure that we have visibility into. And you might also simply want to generate a seccomp profile. For those who don't know, seccomp profiles are a way for you to restrict a process from making certain system calls. And syscalls are how the user space communicates with the kernel space. So there are a host of system level challenges that one might encounter. And spoiler alert, I'm not going to bury the lead today. These can all be solved with eBPF and Inspektor Gadget. So that's what we'll be talking about. These different challenges and how we can use eBPF and Inspektor Gadget to solve them. Okay, so I am going to move to the sort of interactive portion of the presentation. So we have a Menti poll for all of you. And this is basically, if you have your phone and you want to participate, you can go to menti.com. So it's MENTI.com. I'll do it with you guys so that we can all work on it together. And the code is 67698626. And if you join, you should see on your phone a list of basically issues that some of which were listed on the previous slide. And we're curious as to which of these you have the hardest time solving. So feel free to take a second and vote if you'd like. Oh, yeah. And so the code is 67698626. That's the number, and the website is menti.com. MENTI.com. So I will also vote. Cool. Okay, this is awesome. So we have identifying the source of stress on your system is a popular issue that people have hard time solving, identifying when a malicious actor may be accessing critical files, less so the shell opening up on a cluster, and it's always DNS. Maybe you all have DNS all figured out. I could learn something from you all then. Okay, cool. That's super interesting. We are going to move on to the next question. Let's see if can I do it from here? Okay, cool. So yeah, spoiler alert, all of these problems can be solved using eBPF. We're now curious as to what comes to mind when you think or hear eBPF. It could be whatever comes to mind. Also, yeah, please keep it family friendly. It'll show up on here in a word cloud format, so appreciate your willingness to play along and yeah, anything that comes to mind. I'll also put in my answers as well. Cool. So it's creating a word cloud. So the most popular answers sort of get larger as multiple people enter the same. And I'll read some of them out for you all. Thanks for participating too. I think it's so interesting. Okay, so scary, networking, kernel. We are on the kernel track after all. A packet, hard, complicated, magic. I like magic. Performance, programmability, awesome, Berkeley, machine, cool, assembly, firewall, configurable. Wish I knew how to use it. Brendan, Greg. So these are all really good. And today, I'm really hoping we're going to be able to take some of these words around like complicated, scary, wish I knew how to use it, those off the board, because with Inspektor Gadget, we're going to sort of abstract away all of the complexities that are associated with eBPF and really empower you all to use it in a way that makes sense with your system. Alrighty, back to business now. Enough fun. Let's go back here. Let's see if it's going to share. Okay, cool. Let me skip ahead. Okay. So that leads us into our intro to eBPF. As promised, we want to give you guys an overview of eBPF and talk about some of the things that you all put on the word cloud. So what is eBPF? So it technically stands for Extended Berkeley Packet Filter, though its capabilities extend well beyond that of packet filtering. And technically speaking, eBPF is in-kernel bytecode runtime used for things like tracing, security, networking, among other things. And what that actually means is eBPF allows us to work within the kernel in a safe and performant way. So since the kernel is such a complicated space and a sensitive space, we want to be able to understand what's happening in the kernel and even change what's going on in there, but do so in a very safe and performant manner, and eBPF allows us to do so. So the cool thing about eBPF is it brings flexibility to the kernel. So we don't necessarily have to wait for a new kernel release, work with the maintainers, implement a new feature. Using eBPF, we can actually change the behavior of the kernel without having to recompile it, which makes for a really beneficial aspect of eBPF. It also has very low strain from a performance perspective, so it uses a just-in-time compiler approach, which allows it to be extremely performant. And finally, it won't crash your kernel. So eBPF runs through a verifier to make sure that the programs are not going to crash your kernel. So eBPF can be used for a variety of use cases. From an observability perspective, eBPF can be used to measure CPU usage, memory allocation, and similar metrics that can be used for performance troubleshooting. It can also be used for security. So it can be used to enforce access control policies. You can whitelist or blacklist specific system calls. So those are the calls that are coming from the user space to the kernel space, and network connections, etc. And finally, kind of what it's famous for, maybe, eBPF can be used for networking. So it allows for packet filtering and modification within the kernel, like firewall rules. I'll now hand it off to Jose, who will explain some technical concepts for you all that are sort of good to know if you're interested in eBPF.
Okay, now we have three main components when we talk about eBPF, because the idea is that we have the kernel that is executing the normal instructions. So you are in user space, it is running and need to access maybe the devices, needs to access any external device, or need to send data to the network, or need to do any task. But all these tasks in the user space will go into the kernel, and then with eBPF what we do is to specify what is the point when you want your eBPF program to run. So the three components are the hook, we call it. The hook is the way we call the point where the program will be run. So the kernel is executing, reach the hook, and then your program will be executed. That's the definition of this, the hook. It's the point where exactly the point where your program will be executed. So the program itself does nothing if you don't specify when it needs to be run. For instance, to make an example, it will be like every time a packet is being sent through the NIC, at that moment, I want my program to run. Maybe because you want to monitor how many bytes is being sent through that NIC, maybe because you want to block the traffic saying there, but that's the idea. So you specify the point when you want to program to run, and then you specify the program itself, what it will do. Then we have the other component, that is the map. This is mainly for the way you communicate from user space to with the program. So if you need to specify, for instance, what are the NICs that you want to monitor, or maybe let's put it in the other way around. So if the program is monitoring the number of bytes that you are sending through a NIC, where to put those bytes so that you can start in the user space, the program that is the monitoring program that you have will be able to read it. And this is where the maps come from. So the map will be the way to communicate between the program and your user space application that is showing the information. So you have the user space application that is showing how many bytes are being sent, the program that is being executed every time a packet is sent, and then this program will put the bytes into the map, and this one will get it. The communication is asynchronous, so you don't block the sending the bytes through the NIC. You just, every time the packet is going through, is going out, you will put the number of bytes into the map. The packet will continue the execution, the kernel will continue the execution, so the packet will go out from the system, and then from this, you will get information. You will pull the information every time you want. Maybe when there is this kind of statistics, what you do is to do it periodically, every X seconds, every time you want, so you will get the information. Okay, in those X seconds, we send X number of bytes through the NIC. So that's the idea. Those are the three main components: the hook, the map, and the program. Yes, the program.
Cool. Thank you, Jose. So we've spoken a bit about eBPF, and we've talked about how it brings flexibility to the kernel, that's very performant, it's safe, but it's not without its challenges. So it is it does require a pretty steep learning curve and a deep knowledge of low-level systems troubleshooting. So the thing about eBPF is that it is pretty deep in the tech stack and does require a bit of subject matter expertise. And additionally, we can get all of this information using eBPF from the kernel. Super valuable. It's super granular as well. But what's missing is the higher level concepts like containers and Kubernetes resources. So that is kind of where Inspektor Gadget comes into play. So why did the team think to even create Inspektor Gadget? The team recognized that eBPF is super powerful for gathering system information and really getting the details of what is going on in your system, but it's hard. It's not necessarily the most intuitive thing. And once you have all of this super granular data, it's not necessarily immediately useful. It can be overwhelming. There can be a lot of it. So we need to understand this kernel level data within the context of our larger system, and we need to be able to easily export it and use it in a way that makes sense for us. And if we want to do all of these things, there's a lot of tooling and a lot of processes that we need to incorporate into our system to make it happen. You need your eBPF programs themselves, something to manage them. You need to sort of map kernel level data to higher level resources, like I mentioned before, containers, Kubernetes resources. Oftentimes, there's additional processing needing to be done in the user space, and then probably another host of tools needed to export the data. So with Inspektor Gadget, we've created an open source tool and framework for data collection and systems inspections on Kubernetes and Linux hosts using eBPF. So we have this tool that is meant to be a one-stop shop for you to collect the granular kernel level data from your system and understand it in a context that makes sense to you. So the three sort of components that we talk about the project in are gadgets, of course. First, the kind of key component is that these gadgets, they encapsulate the eBPF programs in OCI images, and that's what's actually doing the systems inspection and collecting the data from the kernel. We then enrich the data. So we are container and Kubernetes aware. And so we do all the legwork of mapping those low-level systems concepts to higher-level resources like pods and nodes if you're working in the context of Kubernetes. And finally, we built the project to intentionally be extremely modular. We want it to work in whatever use case that you can think of. So we've made everything sort of a plug and play model where you can collect the data that you need, filter it, format it, and export it to wherever you need in a way that makes sense for you. So with that, Jose is going to give us a demo for you to see this in action.
Okay. Is this big enough? Readable? Okay. So this first example, the idea is to make something very simple that you just get an idea of what is Inspektor Gadget is capable of. And the first example will be to try to use this gadget that is called trace open. So trace open, what it does is to try to trace all the files that are being opened into the system. So we, as Maya said, we are able, or Inspektor Gadget is able to run into a containerized environment, so running to try to trace containers or to trace containers being created by Kubernetes, both of them. In this specific case, I will use the IG version, that is the one just monitoring Linux hosts and containers being created outside Kubernetes. And this example will be like, so trace open, while following my explanation about eBPF, it will be, the hook will be the function that is called every time file is being opened, that is open at, or open. And then the program will just keep track of what is the process that is opening that file, what is the file that is being opened, and the mode. So if it is read and write, or those permissions that is used to open the file. And then Inspektor Gadget will do the magic. So you have to focus, when using Inspektor Gadget, to focus on that. Defining the use cases, so you have the hook and the program. And then Inspektor Gadget will do the magic, Inspektor Magic. So here I'm running Inspektor Gadget, so Inspektor IG run, and then the name of the gadget. And this is the latest version that we released last week. So when I run this, it will get the gadget, install it into the system, and it will install the program defining the hook. So the hook is when the file is being opened, and then what it needs to do. And then you will have this output. So let me create a container here. So if I create a container here, you can see that these are all the files that are being opened during the creation of the container. So we have runc, so we are to show that we are able to monitor to trace the very first operation that are being done by runc just to actually create the container. Then you see all the other file that needs to be opened to create the container. But now if I do something like echo, let's see something in TMP4. So I have the name of the container, that is the enrichment that Maya was explaining before, because we are running a eBPF program, and at the same time we are mapping those events that we are capturing with the high-level concept like containers. So we have the name of the container that I created, the process that ran that, because echo is not actually a process, it's just something embedded in Bash, then the IP, the thread ID, and the file that is being opened, and here the permission that I was mentioning. Here, in case there is any error, like here, probably if I can't do something, oops, sorry, I was blocking the shell. Okay, if I do to open a file that doesn't exist, I have cat that is doing that, the name of the file, and then the error that the file doesn't exist. So we are monitoring every time a file is being opened if that call is successful or not, and then enriching that information with all the high level. In this case, is only the name of the container, but you will be also able to do that in Kubernetes, and you will have all the Kubernetes metadata. Sure.
Is the trace open gadget the thing that determines what the columns are that you're displaying?
Yes.
For the recording.
Okay. The question was if is trace open gadget defining the columns that will be displayed in the output. Yes, every gadget has its own output. You can define it when you create the gadget. You can define like, okay, I want the error. This is the information that the eBPF program is collecting. And then we have a YAML file in the gadget that defines what will be the default columns that you want to show here. But let me show you, that was exactly the next example. So let me show you this. You can use output, YAML, let's try this time. It also supports JSON, and also support, JSON pretty will be the other. And if I run the same thing, it was loading, I think, yet. Give us a second. It is moving? Yes. If I run, okay. It was loading into the system. It was too quick. And then you have here the YAML. You have here all the information. Look that the Kubernetes is empty because we are not running in Kubernetes. But the process, we have Bash, we have the user that executed the system, that specific event, the system calling this time. The parent information, and here the runtime, what is the information we are getting for the container runtime that was used to create that container. And then from this, in the YAML file, you define which of these fields you want to display in the columns. That's something you can customize, sorry. And then just another example will be if you want, for instance, to use the container name. And if I do something, my container, so of course I will be able to trace all the information from the containers that is matching the filter. And this filtering is done in the in the kernel side. So we just try to the first thing we do in the program is to monitor if this event, we are interested or not in this event. If it is not, just discard. How we map the container into the kernel, we use the mount namespace. Because the mount namespace is unique for each container, so we will be able to just trace the events, send the events that we are interested for user space, because that's the most expensive part, sharing information between reading information between the user space and the kernel space. So in this case, if I run something here, oops, wait. If I run something here, I will be able to trace it, but if I create another container just to do that, I will be able to cut something, it will not be traced here. And yeah, I think that's enough, like an initial demo. Let's continue. If you have questions. No. Okay.
Alrighty. Thanks, Jose. We're back here. All right. Let's see if it... It's thinking, sorry. Okay, cool. Awesome. So we ran through sort of the introductory example of Inspektor Gadget and wanted to just reiterate that Inspektor Gadget can be used for a multitude of use cases, and it can be used on the Linux host directly with containers, or it can be used in the Kubernetes context as well. And when it comes to your options for exporting the data, you can export via JSON, you can use Prometheus, OpenTelemetry, you can visualize it in Grafana, or if you'd like to use it for troubleshooting in the CLI, that's a great option as well. And yeah, I think Jose ran through this pretty well. Basically, the three, sort of the components that he laid out earlier in terms of the eBPF program, which is encapsulated in the gadget, the events, which are the hook points, and then the eBPF map as in the interface between the kernel space and the user space. Are sort of the three, or the components that were demonstrated in the demo as well. And I'll just keep moving. I think we hit this stuff pretty well. And yeah, basically, when it comes to the enrichment, we really wanted to make it easy for folks to understand the Kubernetes context and the containers context like you just saw. So we're gonna demo another gadget that you'll be able to see the enrichment yet again.
Okay. So, no. Let me show. This time, oops, we will demonstrate the DNS gadget. DNS is something, you know, DNS. I don't have to introduce this issue. But, okay, so with DNS, the DNS gadget, what it's doing is just tracing all the packets, verifying if it is a DNS packet. We use the heuristic way, which is just checking the protocol and the port that it is using. This is by definition, I think the RFC also say that 53 or 5353. So it's very well known port that you have to trace. I think Washar do the same. Yeah. And so what we do is to monitor all the packets, or if it's a DNS packet, then we try to parse the information and provide all that information to user space. You will be able to see the queries, the response, and in the response if it was successful or if it has any issue. So the idea is to keep it very high level, that you just need to run the gadget and your application is running in your system. In this case, it's a containerized application, and then you will be able to monitor everything that is happening regarding, let me put this smaller to make it more readable. You will be able to trace everything that is happening with DNS. So now I will just, this deploy is just a container generating DNS request, and this is the way. So you will be able to see, let me let it run for a bit. Yes. Now, so the columns will be the source that is generating which is generating the DNS request or response, destination, the command, in this case, this DNS lookup, and the PID, and all this information about the processes, the process that is generating the request, and then we have here the type. So A is for IPv4, AAA is for IPv6. We have now the name here that is trying to be resolved, and I have to put it very big to make it readable, but this is example that I'm trying to resolve in the application, and it is successful. And this is a typo, just be in case in your application you did a typo in the URL, so it is not being able to be resolved. So you have the name that you are resolving and if it was successful or not. Look at this R and Q, this is the query and this is the response. So you have the query when it is going out, and then the response when it's coming back to your system, and you see if it succeeded or not. I think this make really simple to trace DNS. It is just showing you everything. You can filter. We have seen people just keeping very clear. You are able to filter by any field, so you can filter by only responses with answer different than successful. So you just being able to trace exactly what you need, not just everything, but exactly what you need. I think that's fine. I don't know if that's enough for this question, for this one.
Yeah, the Trace DNS gadget in particular is one of our, I would say, more popular gadgets because people find it really valuable to be able to truly understand when a DNS query is, the response is successful or not. So yeah, I think that one people actually, I'm glad we demoed that one because people really enjoy that one in particular. Cool, so now we're gonna get into the gadgets themselves. We sort of alluded to this idea that, oh, the gadgets are what encapsulate the eBPF program, but we wanted to sort of give you guys visibility into what exactly is a gadget and what makes these gadgets what makes up these gadgets, essentially. So like Jose mentioned, there is a YAML file in the gadgets, and that basically encapsulates all the metadata and the important information about the gadgets. So its capabilities, the output formatting like we chatted about earlier, build information. And then, of course, like we mentioned, the main thing in the gadget are these eBPF programs. And there's also the option for a user space module, a WASM file. So if you want to do additional user space processing afterwards, you can use WASM for that. So that's those are sort of the key components of the gadgets. And basically, the way we have it set up is that these gadgets live in an OCI registry, so you can pull the image down from the registry using IG image pull and then run them on your host, which makes it super easy to be able to pull down certain gadgets, whatever you're interested in, and then run them. So while we're on the topic of gadgets, I wanted to give you all some like a high-level overview of the different types of gadgets we have. So I think we have like over 30 gadgets at this point. We have like a huge library of gadgets, some of which our team has written and contributed, but we also have community contributed gadgets as well. So if you're interested in writing your own gadget, you're welcome to contribute to the project. But they kind of loosely fit into these buckets around advise, audit, profile, snapshot, top, and trace. And we can always create a new category for you if you can think of a new idea that doesn't necessarily neatly fit into these buckets. But yeah, we have a ton of different gadgets that do all sorts of different things to meet a variety of needs as it relates to data collection from your system. So you saw a couple earlier, Trace Open and Trace DNS, which are a couple of the popular ones that folks enjoy using. And we are also on Artifact Hub. So Artifact Hub is a great place to find the gadgets, and it's a really cool user interface for you to look at the library of gadgets that exist. So we will now do another demo for you all.
Are we fine with time? Yes. Okay, this time Maya shows some of the categories. Okay, show the categories, and so far we have demonstrated two trace gadget that is collecting the trace in one specific event, but this time we will demonstrate something different. It's for profiling. So when you want to verify, to profile, to see how is the block IO latency in your system, so it doesn't trace a specific event and send it to user space, but more like monitoring all the block IO latency in your system. So if I run it, and I will try something. Let me see if it is able to show it properly, because it's so big. Yeah. Or else it will create a histogram showing where the latency falls. So most of every operation has its own. You are in the kernel. You are able to measure the latency for each block I/O operation. So we are creating a histogram showing how this is the latency is behaving. And now let me try to stress the system to see how it. Yeah. It's clear the change. So I just ran a container that stressed the system, tried to write many times, and it is just the histogram is showing how now most of the operations are falling into an interval that is higher because the system is getting more busy. I think we have similar gadgets that follows this idea also for the round trip time. So you will have the possibility to profile the TCP latency, because the TCP round trip time will show you the latency, and you are able to create this. Many people is using this just to profile the system, the system with an application. Then when they do a new release, try to profile to see what is the difference, and if it is increasing, it is changing completely the difference after a new release. But it is all the profiling use cases that you can imagine.
So in this one, the way you were stressing it was that you were writing excessively to a file,
yes.
Jose, right? So theoretically, like you would see this histogram, you'd see that like, oh shoot, the latency profile, the histogram jumped up, and then you'd be wondering like, oh my gosh, what is going on? I know it's related to block IO. I know something is going wrong, and then you'd probably want to use like the top file gadget after that. So another one of the gadgets that we have is called top file, and sort of the follow-up when you're like, oh my gosh, my system's being stressed, would be to use the top file gadget to then see what actually is writing to the system excessively. What process, I guess, would be how we put it.
Yeah, thanks. I missed that part.
No. Cool, because I think that's what you all were interested in, right?
Yeah.
Like in terms of like what is putting stress on my system. That's kind of when we did the Menti poll, you kind of saw the histogram lets you visualize that my system is being stressed, and then we have another gadget called top file that would allow you to actually figure out that, oh, this process is writing excessively to file. So that is, yeah, that was an awesome demo. I always love the histogram because you can see it just like jump up to that higher latency band immediately, which is really cool. Okay, so moving on, we wanted to also talk about the modes of operation. You can use this in a variety of ways. We've kind of hit on the fact that you can use it on the Linux host, and you can use this IG binary or IG inside of a container. We also have a client server set up as an option where we use a client called Gadget CTL to control the service via an API call. So that is a great way to use Inspektor Gadget on Linux, especially if you're looking to use it in a debugging capacity. You can use Gadget CTL to interact with this client server setup. And for Kubernetes, IG is deployed as a daemon set. So we put a gadget pod on each of the nodes, and we're able to run the gadgets via this daemon set and collect the information that you need from the Linux system and then map it to these higher level Kubernetes concepts. And we also have a Go library API. A new feature that the team recently released is this idea of gadget instance manifests. So if I have a gadget and I want to configure it in a very specific way and continually configure it in the same way, I can sort of package up the configuration in what we are calling gadget instance manifests, sort of these manifest files that I can then share with you or whoever it might be so that you can use, in this case, trace DNS in the exact way that you want. So for example, maybe you only want to look at the DNS requests that are not successful, so or the where the query response equals R, for example. So yeah, you are looking for responses and those that are not successful. So you can configure the manifest file in this way and then share and distribute it, which I think makes using the gadgets even easier. Okay, and finally, like we've been saying throughout the presentation, you can export it in export the data in a variety of ways, whether that's via JSON file, using Prometheus, or using OpenTelemetry, which is another open source project for those that don't know that's kind of become the standard for observability and data collection. So I think with that, we have one more demo for you all.
This is the one that makes that is more complex. So let's see the demo effect, if it will work, everything. Yeah. Okay. Yeah, it is on, right? Yes, it is. Okay, so far we have demonstrated how to use Inspektor Gadget only for containers. So we have been using the IG binary. This is the one tracing containers and Linux hosts. But now we will move to a Kubernetes environment. So I have a cluster here. And let's try to deploy Inspektor Gadget that use Inspektor Gadget now in a Kubernetes environment. So the first thing, how you use Inspektor Gadget in Kubernetes is that we created a kubectl plugin. So it is easy to install. You can use Crew, you download directly the binary. And OK, I already have it here. And now what you can do is, so you use kubectl gadget version, and then you have the client version, and then the server is not available because we haven't deployed it yet. And let's deploy it. No. Let me, my notes, because I have, oh, OK, this one. So normally what you will do will be kubectl gadget deploy, and it will deploy the daemon set that will run a pod on every node. So that pod will be in charge of collecting information from every node and then send it back to the kubectl Gadget plugin that will display all the information together. So in the same terminal or the same output, you will have the information for what is going on in every node. You will have everything merged in the client. But this time, given that we want to, the demo is for exporting this data to to Prometheus through OpenTelemetry. So we will enable OpenTelemetry listener, and we will specify the address where Prometheus needs to go to get the information. So we run it. Internet, helps me, please. OK. So we run it, and we now have Inspektor Gadget in our cluster. We see that the server version is now there. And what we are going to do is to create, just to trace, to use this gadget. So it's the same notation as we demonstrated before. So instead of IG, you use kubectl Gadget, run, and then the name of the gadget. At this time, we will run trace exec, that is tracing all the exec system call. It is basically all the binaries that are being executed into the system. And this time, we will have the visibility on to the whole cluster. So if I create a pod here, OK, nice. So we have, again, this time we don't have just the container name, but we have all the Kubernetes metadata, the namespace, the container, the pod namespace, and the node where it is running. And again, the whole information of the process that is generating the event. And this time, OK, this is very small, but yeah, the command that is being executed. So if I do, I don't know, ls, we are running ls, specific where it happened, and everything, the arguments, and the error also when you are trying to, the exec system call fails. And also here you have the possibility to make, to filter for all the fields that the gadget is exposed. And let me do this, something like, this is the same I was mentioning for the DNS, and that also Maya do in the manifest file. So you are able to filter by a specific field. In this case, we want to catch every time someone is trying to execute a shell, to create a new shell. So we are filtering for the process name bash. So this is the way people are usually doing remote code execution. So they download something and then pass it to bash to execute that information. Well, I mean, to execute whatever they want to do. So if I run ls, it will show nothing. But if I create a new bash, it will capture that. But now, let's bring this to another level. Just export this information to Prometheus. So what I'm going to do is to use this manifest that Maya described before. So I created this manifest. It is that instance spec and the name of the gadget that we were executing before, the same of the CLI. We are giving it a name. And here the filtering, the most interesting part. So we are monitoring all the namespaces to get it all around the cluster. Again, filtering only the bash, because this is the example we are running here. And here start the OpenTelemetry stuff. So we define a name. This is the metric that we want to export. And here are all the configuration. So first, I will go through it. First, enable the gadget, telling the gadget, OK, I want it to collect metrics. Then we are creating, given that this is a gadget that actually is monitoring all the events and send you back all the events that every time an execution happens, I don't want to do that. I don't want to send this information. Actually, what I want to do in this case is to create a counter for that. So every time someone tries to execute a shell, it will start counting it and send that count to expose that count to OpenTelemetry so that with Prometheus we can get that information. So you will be able basically to keep counting the number of times someone is trying to create a shell in your system. And what we will do is, okay, why I want a count, what I do with that counter, I will show later. You can create an alert in Prometheus to let you know every time this happened. The counter is bigger than 0. That's the way you will create you will use this counter. Then, what is the information you want to send with that is the key, they are the keys for the metric. So you want to have the namespace, the pod, and the container name of that metric. So you will be able to aggregate for every the number of shells being executed in a specific namespace or in a specific pod, and these are the granularity you will have for exporting it. Let me, now, okay, so now to run it, it is very similar to what we do for applying a YAML file in Kubernetes. So you got kubectl gadget run -f, and then passing the YAML file, and this is the annotation I described before. And this is a very specific thing that now that we are not just tracing everything that is happening, we want to run it headless. We want to run it in the background. You don't want you don't want your terminal to be blocked there. You want to run it in the background. So with that detach flag, you will be able to use that. So you can now kubectl gadget list, and you have your gadget running in the background in the cluster. And if you want, you can also attach alert, or maybe just B. We have just one, so the ID. You will be able to see that. Now, if I run bash, it is there. And at the same time, it is now increasing the counter to 1. So from Prometheus, we will be able to get that. And let's do it very quickly, because the time, let me see what I'm missing. Yeah, I think we can go directly through. I hope I configure the yeah, the port forward. Yeah, it's working. Now, we have Prometheus here, and this is the name of the metric we are exporting. So if I execute it, we have 1. That is the bash that we executed. And now let's do it about the alert. And okay, I had already configured the alert. I missed to show that. Okay, but now let me show you what I did. It was basically, no, here. VI, Prometheus, yes. And here what I did. Okay. In my Prometheus configuration, I created this alert that every time shell execution total is greater than 0, it will generate an alert. So this is something you can do in your Prometheus, and it will generate this value. So every time I run bash here, I don't know, another 2 or 3, it will increase here, and you will receive the alert of the notification that it increased. Of course, Prometheus is getting that information every minute or 30 seconds. I don't remember how I configured it, but it will not be immediately, of course. But I mean, for the demo. And yes, I think that's, yeah, it will take sometimes just 1 minute, I guess. But I think you get the idea of what you can do. So you have the traces, we are getting the events, and counting the number of events to generate alerts. You can do the same for, I mean, maybe you don't want to generate an alert for a DNS failure, but yeah, this is open to all the use cases that you can imagine in your specific situation, and these are the means. Maya?
Cool. Yeah, I love that particular demo because you really see the end-to-end use case sort of in real life in terms of a security use case, because like Jose mentioned, when using trace exec, you can identify when the bash process is running, and that could be indicative of a remote code execution. So it's like really cool to be able to see that, like, hey, you can use Inspektor Gadget for these security alerting use cases as well. So yeah, I guess in the very first slide, basically, that we showed you all, we kind of alluded to the fact that these are a ton of system challenges that can be solved using eBPF and specifically Inspektor Gadget. So here on this slide in purple, I've put the different, or sub-bullets, I've put the different gadgets that are used to solve these issues, and we covered a bunch of them today. We used trace DNS to look into DNS queries not resolving. We used profile block.io to create the histogram that helped us identify the stress on the system coming from a particular container, and then subsequently we can use top file to identify what exactly is going on. And we also used trace open at the very beginning just to demonstrate the gadgets, and trace exec as well just now with the shell opening on a Kubernetes cluster. So we ran through a lot in the last hour or so. And just to close out, what's next? What's on the roadmap for our project? 1.0 hopefully is coming soon. We're really excited. The project has reached a really good point, and we're wrapping up some things, but I think 1.0 is on the horizon pretty soon. We also have a new graphical user interface, a GUI, that one of our maintainers has been working on. So everything you saw today was primarily through the CLI, but we're also working on a nice desktop app for you all as well.
Yeah, just to connect it to the question about the columns from the UI, it will be very easy just to add and remove columns to make it easy, because in the CLI you look that I need to increase the font and it was difficult to show all the information, so the UI will solve all that issues.
Definitely. And we're also working on gadgets around enhanced CPU profiling and off CPU. And of course, we are continually wanting to understand the community's priorities and needs, and of course, document everything super well. So a call for action for you all. Definitely please think through the examples we went through today. Think about how eBPF could be used to enhance the projects that you all are working on, and see if we have a gadget that can help you, or even better, if you want to brainstorm a gadget that covers a use case we haven't even thought of, we'd love to hear it. So with that, we are on Slack, we have our website, our GitHub, all that stuff, and we also have a short, 5-question survey about troubleshooting use cases that we'd really love to hear from you all, and it would really help the project a lot to hear your all's perspective.
Yeah, I just want to say that in Slack, what I like from Slack, the Slack channel, is that people maybe don't know how to implement things in eBPF. They just have the idea of, okay, I want to monitor this, how I can do it. And there are other people in the community or the maintainers that can share, okay, what you should do, or what you could do is maybe this hook in the kernel, and you will provide you this information, and we help you to create your own gadget. So you don't need to be an expert or to know very well eBPF. That's the idea, because Inspektor Gadget will provide you helper functions that you will use in your program, and we will help you to find what is the best hooks to use, and then you will create the program because maybe you want to monitor to get one information or another. But that's something that you can just share the idea in the Slack, and the community together we come up with something, because everybody's like, okay, yeah, that's interesting, how we can do that. So it creates a conversation that everybody can participate. That's nice. So welcome to join.
Yeah, please join us. And with that, thank you. And I think we have a couple minutes for questions. So thank you so much.
Thanks for that very deep dive into Inspektor Gadget. It was a lot of good demos. I sort of had 2 questions. The first one should be easy. The exporter functionality to Prometheus and OTel, that's running in your WASM runtime, or?
That's running in what?
Is it
no,
running in your WebAssembly runtime?
No, that's running in the gadget, in the gadget pod inside the Kubernetes. So every gadget pod with the export and an address at
Okay.
HTTP, and you will collect the information.
So
The
yeah.
the WASM, no, the WASM is only for processing the data. So one example for WASM will be the DNS gadget, because I describe it like, okay, you get the packet, but then you need to parse all the packet to get all the DNS information.
I
That's
see.
super difficult to do it in eBPF. So what we do is to send the packet to WASM, and there are
Gotcha.
a
And
lot
then
of
that gets
library.
relayed to the pod service that's doing the export functionality. Is that correct?
That is in the Golang part, in the pod that is exposing
Yeah.
that.
And then the second question was, it
Yes.
wasn't obvious to me, like how you have this base module that's doing the BPF logic to get the trace exec, but then is it in YAML that you're describing, okay, I'm counting this specific thing and then I'm turning it into this specific metric in Prometheus, or where is that, how do you do that mapping?
Aggregated to metrics.
Okay, that what we do is to in the again in the pod, what we do is to count those events and create a counter that is exposed through open telemetry. I don't know if that answer your question.
Yeah, is that in a DSL or is it in YAML? What was the format?
How do you specify what do you in the YAML, in the manifest? Yes, in the manifest you specify like all the filtering, all the things that specific event you want to create, and then just say create an implicit counter, and it will do everything for you. In the YAML, yes. Sorry. Okay.
Just one more, and we can chat after.
Yes.
Okay, so I was looking at your documentation while you were going through the presentation. Could you elaborate a little bit on the security mechanisms that you have to limit the gadgets that can run? Because obviously I'm kind of afraid of just fetching code from the internet and running straight into the kernel.
Yeah. What we are doing is that when you deploy Inspektor Gadget, you deploy it, you can specify a key where your gadgets were signed. So you will be able to just allow running gadgets that you created with your specific key. So we have this public-private key mechanism to allow you just to run what you are sure that you created. And of course, at that point, it's your responsibility to know what you are running. But at that point, you are sure that nobody is loading eBPF programs doing random stuff or insecure stuff that trying to do something malicious, but it will there will be just your gadgets. So that's the way we are doing. We are signing all the gadgets, and that's we verify that all the gadgets that you are running were signed with the key you specified during the deployment. Of course, in the deployment, it is only the admin that will be able to deploy, so that's the way we provide the security.
Thanks, everyone.
We are in the booth if you want. If you have any other questions.